This lecture is on special products. We'll start off with the FOIL method. So the FOIL method is a shortcut for multiplying binomials. Consider the following abstract case. Binomial a plus b times quantity c plus d. So notice that if we did this our old way, we would have a plus b distributes to the c, and then the quantity a plus b distributes to the d. And then the monomial c distributes to a and b. The monomial d distributes to a and b. And we get ac plus bc plus ad plus bd. But it turns out that there is a shortcut to getting this result. So if we take our a plus b times c plus d, and then multiply the first terms, then we get a times c. And then multiply the outside terms here. So that's plus AD. Then go ahead and multiply these inside terms. Let me label this outside one here with an O. And that's an I there for inside. So BC, so plus BC. And then lastly, well, we have the last terms. So B times D. This is where we get this acronym of FOIL from: first, outside, inside, last. And as you can verify, AC, BC, and BC, AD, AD, BD, and BD. Let's use this method to multiply the following products of binomials. All right, so here we have x minus 4 quantity times the quantity x plus 5. So let's first rewrite the expression. So the quantity x minus 4 times the quantity x plus 5. And then we do our first multiplication. So that's x times x. We do our outside multiplication. X times 5, so plus 5x. We do our inside. So that's a minus here. So it's important that we have minus 4x. And then we do our last multiplication. Negative 4 times 5. So minus 4 times 5. X times x is x squared. 5x minus 4x is x. 4 times 5, 20, negative, so minus 20. And we'll leave it as an exercise for the viewer to use our previous method of distributing the entire binomial to each individual term in the second binomial. This example is a little more tricky because we have coefficients for our variables, unlike here where our variables had ones for coefficients. So we have negative 2x minus 3 as a quantity times the quantity 7x minus 5. So we have our first multiplication, negative 2x times 7x. We have our outside, negative 2x minus 5. So you can always just default to a plus sign and then put the terms into parentheses. Or inside, so default operation between each terms, plus sign, and then put everything in parentheses, negative 3 times 7x. And then the last multiplication, negative 3 times negative 5. So default operation is addition, then negative 3 times negative 5. Negative 2x times 7x is negative 14x squared. Negative 2x times negative 5 is positive 10x. So we have plus positive 10x, which is just plus 10x. Negative 3 times 7x is negative 21x. So plus a negative is minus. We have minus 21x. Lastly, negative 3 times negative 5, positive 15. So plus 15. And we combine like terms and get negative 14x squared minus 11x plus 15. And that's our answer. Next topic is the difference of two squares. So the product of a term and itself is called a perfect square. And here are some examples. X squared, because it is the product of x with itself. A to the fourth is a perfect square because it is the product of a squared with itself. 4 is equal to 2 times itself. 16 is equal to 4 times 4. 81 is 9 times itself. Now, when we encounter polynomials that are a difference of two perfect squares, then we have a nice result known as the difference of two squares. If you have something squared minus something else squared, then that is equivalent to a minus b times a plus b. which means if you have something of the form a minus b quantity times a plus b quantity, then it's going to multiply into this, and you can skip these steps. So the reason is because, say you have a minus b times a plus b. Well, first multiplication, we get a squared. Second, a plus b. Or, excuse me, ab, a times b. Inside, minus b times a, so minus ab. And then outside, negative b times b minus b squared. So these cancel, and we have a squared minus b squared. So memorize this. Let's try our new formula out on this product of x plus 4 and x minus 4. So this is guaranteed to, since it is of this form, to take whatever we have here. Okay, so that's x. Square it. Minus sign. And then whatever we have in the second position. And we square that. Then we get x squared minus 16. And if you're unconvinced, you could use FOIL, x plus 4 times x minus 4. So x times x is x squared. X times negative 4 is minus 4x. 4 times x is plus 4x. Then 4 times negative 4 is minus 16. Middle terms cancel, and we have x squared minus 16. But it's quicker if you notice that what your product corresponds to a difference of two squares. All right, so multiply. So notice this is of the form something minus something, and then the same thing here is here, but it's plus is the operation, and then the same term here. Well, whenever you have something of that form, we know from our difference of two squares formula, which we proved above, it's the same thing as whatever you have here and here squared minus whatever is in the second slot squared. So we get something like this. And it's whatever is in the first slot goes here. And whatever is in the second position goes here. 2x squared is 4x squared. And then minus 3y squared is 9y squared. And that's our answer. All right, can we apply difference of two squares here? Well, we have the same thing here and here. We have minus and plus, and then the same term in the second slot. So we can. And we get b squared minus, as that's built into the formula, 2/3 squared. b squared is b squared, and 2/3 squared is straight across. 2 times 2, 4. 3 times 3, 9. So b squared minus 4/9. And that is our answer. All right, now we're going to multiply here. We're seeing exponents, large exponents, but the formula holds because note, we have binomial times a binomial. We have subtraction and addition. First terms agree on the left. Second terms agree on the right. So we get whatever the first term is squared minus whatever the second term is squared. So a to the 4th and 3b to the 5th. Recall that we multiply exponents. 4 times 2 is 8, so a to the 8th. And then minus, here we have 3b to the 5th. So that's 3 squared, 9. And b to the 5th squared, multiply exponents. 5 times 2, 10. So a to the 8th minus 9b to the 10th. And let's indicate that as our answer. Perfect square trinomials. A perfect square trinomial is the square of a binomial. When the first and last terms of a trinomial are perfect squares, try to see if the factorization is the square of a binomial. So let's derive formulas for squares of binomials. Let's at least do the first one. So a plus b squared means a plus b times a plus b. Using FOIL, we get first terms multiplied together, so a times a. Outside, we get a times b. Inside, b times a. Well, that's the same thing as a times b. And last, b times b. And a times a is a squared. Note we have two ab's, so we have 2ab. They add together to be 2ab. And then b times b is b squared. So if you have something of the form something plus something, and then that sum is squared, it's guaranteed to be the first something squared plus 2 times the first something times the second something plus the second something squared. When it's a difference, then you get a squared minus. So it's the same structure here, except the first operation is subtraction, and then 2ab plus b squared. Let's test these out. So n plus 3 squared, this is a binomial squared. So use a plus b squared equals the first thing squared plus 2 times the second thing, or the first thing times the second thing, plus the last term squared. So we have n and 3. So this will factor out, FOIL out, multiply out to be n squared plus 2 times n times 3. And then plus 3 squared. So there's a nice symmetry to these formulas. And then we get n squared plus, let's use our associative and commutative property, multiply 2 and 3 together first. So we get 6n. And then 3 squared is 9. N squared plus 6n plus 9. Four x cubed minus 3y squared, quantity squared. So we want to use a minus b squared equals whatever a is squared minus 2 times whatever a is times whatever b is. And then always plus whatever b is squared. So this 4x cubed, even though it has multiple factors, numerical factor of 4, 3 factors of x, that is our first term. That's like our a. So we get 4x cubed squared. And then minus 2 times the first term, 4x cubed, and the second term, 3y squared. And then the last term, 3y squared, squared. And then here we square the 4, get 16, and square x cubed and get 3 times 2, 6, so x to the 6th. Here we have minus 2 times, let's multiply these together first. Multiply numerical factors, 4 times 3, 12. X cubed times y squared is x cubed y squared. And then here, well, 3 squared, 9. Y squared, squared, y to the 4th. And then we have 16 x to the 6th. 2 times 12, 24, so minus 24 x cubed y squared plus 9 y to the 4th. All right, again, a little bit faster. This is a difference. This is a difference of 2 terms squared. So we get the first term squared. We have minus here, so it's minus 2 times the first term and times the second term. And then plus the last term squared. So we square this and get 64a squared. We multiply here and get 16. And then 16 times 5 is 80. So negative 80a plus 5 squared, 25. Lastly, we see a square of a sum of two terms. So we get the first term squared, and plus 2 times the first term times the second term. So 3z to the fourth, 2y squared. And then plus 2y squared squared. So here we get 3 squared, 9. Z to the fourth squared is z to the eighth. The next term we get 2 times 3, 6, and then 6 times 2, 12. Z to the fourth times y squared is y squared z to the fourth. Then lastly, 2 squared, 4. Y squared squared y to the fourth. And that is our multiplied out expression. And that concludes this lecture.